Welcome to Dr. Zahir Math. If you enjoyed this video, don't forget to hit the subscribe button and click the bell icon to stay updated on my latest videos. Today, I'll be doing the introduction section 1.1, which is terminology, definition, and types of differential equations. I'll break it down into easy steps to make sure you can follow along. Be sure to take notes on the important points. If this explanation helps you, please give the video a thumbs up. Feel free to share your thoughts or ask any questions in the comment section below. Let's start 1.1 terminology, definition and types. First, we'll go for definition. Already, I told you the definition in the class itself. What do you mean by differential equation? A differential equation means it is an equation which involves a function, right? And its derivatives. What do you mean by derivatives? Derivatives means dy by dx. So if the equation has dy by dx, then that equation is called as differential equation. In other way, you can take it from the physics or from the previous calculus 1 course also. So we write it as dx by dt. This is also differential coefficients, right? So distance traveled by time taken, right? This is also having the differential coefficients. So it shows how the function changes with respect to one or more variables. In simple way, I can tell it relates the rate of change of quantity. This is the rate of change, okay, to the quantity itself. So this is the definition of differential equation. Next, we go for the types of differential equations. There are two types of differential equation. One is ordinary differential equation, okay. Another one is partial differential equations, okay, right. So last semester, we studied in calculus 3, derivative d as well as the partial derivative dou, right. If the differential equation consists of d, then it is called ordinary differential equation. If the differential equation consists of dou, then that differential equation is then that differential equation is called partial differential equations. See the examples which I have given. Dy by dx. So this is ordinary differential equation. D ordinary differential equation. Dy by dx ordinary differential equation. Dy by d square y by dx square. Dy by dx ordinary differential equation. D cube y by dx cube. D square y by dx square. And dy by dx ordinary differential equation. In short, they will write ordinary differential equation as ODE. So this is an ODE and this is an ODE, right? And this is an ODE, right? And this is also an ODE, ordinary differential equation. I hope ordinary differential equation is clear. Let's go for partial differential equations. Okay, right. Just now I said partial differential equation means it consists of dou in your equations, right? Right. Dou can be also written as f suffix x. Also, you can written as what? U suffix x if the function is on. All these things you know very well, right? And if this is also dou y by dou x, right? So here examples I have given with English words. That is name of the equation I have given. Why? Because in calculus 3 already you studied in module 3 heat equation, wave equation and Laplace equation. I hope you remember. Dou u by dou t equals alpha dou square u by dou x square. There is a dou, there is a dou. So it's partial differential equation. There is a dou, there is a dou. So it's partial differential equation. There is a dou, there is a dou. It's a partial differential equation, right? And these three equations already you studied in calculus 3. But the last equation, the Poisson's equation, you have not studied, right? Dou square u by dou x square plus dou square u by dou y square equals function f of x comma y. If the right hand side is function, then that equation is called as Poisson equation. So this equation you will study in the next course, which is numerical methods, okay, or numerical analysis. So there we will try to find the numerical solution for this Poisson's equation. So now it's clear what is the partial differential equation. That means it's dou, okay, right. Now let's go to the next definition, order of a differential equation. What do you mean by order of a differential equation? The order of the differential equation is defined as highest derivative given in the differential equation, right? So look here, this is a differential equation. So dy by dx is there, so it's first order. So in the equation, if it is d square y by dx square is there, it is second order differential equations, right? So this is meaning of order of a differential equation. So in short, if you want to tell how many times the function is differentiated in the equation, then that is called order of a differential equation. Or you can simply remember the highest derivative in the equation is called as order of the differential equation. I have given some examples also. You can see the examples. Order of a differential equation, right? Yes. Now I have given some examples. Look at here. Just let me, you don't see the order. Just look at here. So let's see the differential equation order. So just see dy by dx. If there is dy by dx, the order is 1. So look here, d square y by dx square is there, dy by dx is there, okay. So which is the highest order? The highest order is d square y by dx square. The highest one is d square by dx square, right? It is not d square, it is not dou, it is d square y by dx square, okay. So it means the order is equal to what? 2. Look at this differential equation. We have d cube, we have d square. So the order is going to become what? 3. Which is the highest number? D cube. Let's go for the next equation. I have given some examples on partial. This is dou square and this is dou. So which is the highest order? Order is equal to how much? 2. Look at here. D power 4, d square. So highest order how much? 4. So in this way, the order of the differential equation is defined. I hope you understood what is the definition of order with the help of these examples. Okay, right. Let's go for the next one, that is linear and non-linear differential equation. These are the two definitions. Most of the time the students get confused with this idea, linear and non-linear differential equations. Let me tell you clearly, please try to understand carefully. Linear differential equation. Usually the differential equation consists of, let me give an example, dy by dx plus y is equal to 0. For example, I'll give like this. Okay. So this is the differential equation. Now in the class I told you y is a dependent variable. Yes, I gave some examples also from the day-to-day life. I hope you remember, right? So y is a dependent variable and the x is called as independent variable, right? Y is a dependent variable and x is what? Independent variable. Okay, right. Now what is the definition of linear? The dependent variable y and its derivatives appear to be power of 1. So it means the dependent variable. So you must have y as power 1 and dy by dx should have power of 1. That is, the derivative must have power of 1. So it means, look here, dy by dx, okay, plus y is equal to 0. Power is 1, okay. Here also power is 1. Don't see the order, power, power. Don't see the order, power. Order is here, power is here. So the order of the differential equation is 1, but the power is 1. If the power of the derivative is 1 and the power of y is 1, then it is called linear differential equation. Let me give you one more example. D square y by dx square, okay, plus y is equal to something I gave 4, for example. So, okay. Now look at this differential equation. The power of y is 1. Teacher, the differential coefficient, power is not 1, it is 2. No, this is called order. So what is its power? The power is 1. So y power is 1 and the differential coefficient's power is also 1. So therefore this differential equation is called as what? Linear differential equation. Okay. So there is an example given here. Dy by dx plus 3y is equal to 5. So the derivative power is 1 and the y power is also 1. Therefore this equation is called as what? Linear differential equation. Okay. Let's go for non-linear. Here is the place you get confused a lot. So nothing to worry. Let me explain it very clearly. So the same idea, dependent variable y. Okay. Look here, there is a word r, two places, right? So r means either this or that. So the dependent variable y and its derivatives appear powers greater than 1. It means y power more than 1, right? And dy by dx, these powers also more than 1. Only dy by dx, teacher? No. D square y by dx square, d cube y by dx cube, everything, okay, if the power is more than 1. So teacher, it should come together? Not necessary. If the y power is more than 1, and if dy by dx or d square y by dx square or d cube y by dx cube, if their power is more than 1, then that type of equations are called non-linear. Not only this, up to this we finished. Let us go for this one. Or multiply together. What do you mean by multiply by together? Suppose there is an equation y and dy by dx is multiplied. If this situation comes also, then it is non-linear. So we have three situations in this. How many situations are there? We have three situations. What are the three situations? Let me explain again. The first one is y power. If it is more than 1, it is a non-linear differential equation. And the derivatives, if it is dy by dx or d square y by dx square, anything higher order, okay? If the power is more than 1, when I say power, I am putting the brackets, look it carefully. If the power is more than 1, then it is a non-linear differential equations, okay? This is second situation. And the third situation is, if it is multiplied together. What do you mean by multiply together? Y and dy by dx multiply together. It's only dy by dx, teacher, not only y. So it can be d square y by dx square, it can be d cube y by dx square, something like that. If this situation comes also, then it is non-linear differential equation. Not only these three situations, there are some more situations will lead the differential equation to non-linear, okay, equations. Let's go for some examples in the linear differential equations. Look at the differential equation. Don't look at the English words. Okay, right. Look here. What is the power of 1? dy by dx power is 1. What is the power of y? 1. So this is linear differential equation. So what is the power of the differential coefficient? 1. What is the power of the differential coefficient? 1. And what is the power of y? 1. So it's a linear differential equation. Right? Yes. Now look at here, right? So what is the power of this differential equation? 1. And what is the power of this differential equation? 1. And what is the power of y? This is going to become linear. And what is the power of this differential equation? 1. What is the power of this differential equation? 1. And y power 1, which is going to be linear. So we can also say all these ideas, whatever I said for ordinary differential equation, okay, which applicable for partial differential equations also, PDE, okay. So this is the PDE, partial differential equations. So the power is also going to become 1. The power is also going to become 1, and it's going to become linear. So these are all some examples for linear differential equations. Let me go for non-linear differential equations. Okay, right. Look at here. The power of dy by dx is 1, but the power of y is what? 2. So it is not a linear differential equation. Okay, the power of d square y by dx square is 1, but you have sine y. See, that the dependent variable here. What is the dependent variable? Dependent variable means, okay, this is y. So you have a functions on sine y. So what happens? Exactly, this is going to become non-linear. And I told you, not only y powers more than 1, and not only derivatives power more than 1, if sometimes if y multiplied by derivative, it is also non-linear. So look at the situation here, y multiplied by dy by dx. So it is a non-linear differential function, and the equation is called non-linear differential equation. Okay. And also here you see y multiplied by dy by dx. So this is a non-linear differential equation. So when I put cross mark, it is non-linear differential equation. Okay. Right. So the next one, there is a e power y is there. So it is non-linear differential equation. Now let me go back to the previous slide. There is one e power x. You can see that in the equation. Teacher, there is a e power x is there. You didn't say this is non-linear. I told you dependent variable. The whatever I told you in this table, all these things are based on the dependent variable y. That must be, you should be careful. The dependent variable y. Look at all the equations, all the functions here. Y. Okay, right. But in this equation, it is e power x. That is why this is what? Linear. But when you come to the examples for non-linear, this is e power y. So it's non-linear. Okay, right. Let's go some more examples. Suppose you change the dependent variable y to another variable. Look at this differential equation. This differential equation, what is the dependent variable? The dependent variable is u. Can you see that? The dependent variable is what? U. So you have to treat as a dependent variable u. Even though this power is 1 and the dependent variable u has a power more than 1. So imagine this is like a y. Okay, right. So this is a non-linear differential equation, right? Yes. And look at this one. This is the dependent variable y multiplied by derivative. It's something like y times dy by dx. Look at here, the idea here. Y times dy by dx. So this is going to become non-linear differential equation. And look at here again, it is y square. So it is non-linear differential equation. And this is power 1. So here no problem. But cosine is coming. Cosine is coming with u. U is a dependent variable. Okay. U is a dependent variable. When u becomes a dependent variable, what happens? Cosine u becomes non-linear. Okay. Right. Suppose in this place the differential equation. For example, dou square u by dou x square plus cosine x is equal to 0. Suppose this is the differential equation given. So this is going to become power 1 and there is no u. So this is cosine x. X is an independent variable. Can you see that? This is the independent variable. So this equation is going to become what? Linear differential equation. This is not linear. But here it is given as what? It is cosine u, where u is a dependent variable. So it's a non-linear differential equation. Let's go with the last example, which is y multiplied by derivative. When there is y multiplied by derivative, non-linear. I gave you example y multiplied by dy. And I told you not only y multiplied by dy, okay, y multiplied by dy also non-linear, and y multiplied by d square y over by dx square also non-linear. Keep in your mind. Sometimes in the exam, dy by dx, they will give it as y prime also, or y dash they will give. So keep in your mind, y prime is nothing but dy by dx. So did you understand everything now? Non-linear differential equations? Yes. Now I have given some examples with a mixed linear, non-linear, everything. Look here. What is the power of this differential? 1. What is the power of this y? 1. So it is linear. Okay. And what is the power of this differential coefficients? 1. And what is the power of y? 2. If it is more than 1, it's going to become non-linear. Okay. Right. Next, I told you sometimes it will be given in terms of y prime. So what is y prime? It is dy by dx. Okay. Plus, okay, y multiplied by cosine x. Y multiplied by cosine x is equal to what? 0. Teacher, this is power 1. Okay. And you said cosine x is a dependent variable. So it's linear, you said. But at the same time, y is multiplying. Can you see that? Y is multiplying. Okay. Y and y dash are not multiplied. I have given here y and y dash have, even though have power 1 and also not multiplied, but cosine s is just a function of x. It is given. Okay. Right. So y and y prime have power 1 and y is multiplied and are not multiplied with cosine x. So just a function of x. So automatic. Sorry. I'm just confused. Sorry. So what happens? It's a linear. Okay. Y dash is there and cosine x. Sorry. So cosine x is there and y is there. So it's going to become linear. It's non-linear different. No. It's a linear. Sorry. So because y and y dash have a power 1. Okay. Yeah. Right. And this is even though multiplied, but x is a dependent variable. Once again, reframe the statement. Look carefully. Y dash plus cosine x y. Okay. Y dash, the power is 1. Okay. And the cosine x is a dependent variable or independent variable? Independent variable. And this y is also linear. So it's going to become a linear function. Right. Sorry. Keep the statement. I'll recollect. This is a linear function. Next we go for non-linear function. This one. Why? Because y power 3. Okay. This is linear. So this is power is 1. And this is power is 1. And this is power is 1. So linear. Right. And the next is non-linear. Y. There is a sign y is there. So non-linear function. The next you have e power x, but at the same time it's multiplied by y. It is not e power y, so it's linear, right? Suppose in this place e power y is there, then definitely it will be what? Non-linear. Okay, right. The next is you have y, ln y situation is there, so it's going to become a non-linear function. Okay, so let me come back to this question, right? This question is a linear. Why? Because cosine x, cosine, it is not cosine y, it is cosine x, so it is free with independent variable. Okay, yeah, right. So therefore it is a linear function, right? So that's all for today. So let me wanted to say thank you for watching this video. I hope you found it helpful. If you have any questions or need further clarification, feel free to leave a comment or get in touch with me during the class hours. Don't forget to like or subscribe and share it with your friends. Stay tuned for more educational content on differential equation. Thank you once again. Bye bye.